Hello viewers, welcome to LFX live class, and today we'll be teaching physics. The topic will be dimensions of physical and derived quantities. I've noticed that some students find it so difficult to understand it. I hope by the end of today's class everything will be sorted out. So now before we start, we'd like to know what is dimensions. Dimensions are like building blocks of physical quantities. Not just physical quantities, but also derived quantities. And now, dimensions are mainly based on fundamental quantities. We have three main letters for dimension, which is M, L, and T, where M is the mass, L is the length, and T is the time. We also have others like current, which is ampere. We have amount of substance, which is mole, and all that. But today we'll be focusing mainly on the M, L, and T aspect. So now, M is mass. We all know that mass is measured in kilogram. L is length. We know that length is measured in meters or centimeters. T is time. We know that time is measured in seconds, hours, and minutes. Now we'll be using these three letters to form dimension. If you remember, the first quantity we're starting with is, we can start with the ones that are measured in meters. For example, length, breadth, width. We have height. We have amplitude, and so on. All these written here are all measured in meters. We also have distance. So now length is measured in meters, breadth the same thing, width the same thing, and all others. So now, if you are given a question, you're asked to leave your answer in dimension, and the question came as height. You already know that height is measured in meters. And since it is measured in meters, the dimension will fall under L. So now, any quantity that is measured in meters should fall under length, which is L. Breadth, since it is measured in meter, it will also be length, which is L. Now we go forward. For other quantities like velocity, acceleration, force, pressure, we'll be forming their dimensions today. Now remember, velocity is the rate of change of displacement with respect to time. Mathematically, you can say velocity is equal to d over t, where d is the distance and t is the time. Now, if you are asked to form the dimension of velocity, remember, distance is measured in meters, and I told you, any quantity that is measured in meters, the dimension will be length. We have divide. Now, time. Remember, the dimension we are dealing with is M, L, and T. So, we already have M, we already have L. For time now, the dimension is T, it's already there. So, no need to put T under. And the rule states that nobody should be up and no one should be down. So, we are going to take this T up since it is down. So, all of them will be on the same line. Now, L is here, T will come up. Remember, we can find only one T here. Law of indices, once one is going up, it becomes -1. So the dimension of velocity is LT raised to power -1. Going down to acceleration. Acceleration is also the rate of change of velocity with respect to time, which is velocity divided by time. Now, to form the dimension of acceleration, we have found the dimension of velocity. So no need of killing ourselves. We just take this and put it up, which is LT raised to power -1 over time. If time were to have dimension, it will also go in t. So we'll put t down. And remember the rule again, there should be no one up and there should be no one down. So now, bringing all of them in one line, LO, remember there is one here, t, what is written here is -1. I told you previously, once this one is going up, law of indices, 1 will go up. Since there is t here and there's t here, we'll pick 1t. So now this one will go up and change to -1, which is now equal to LT -1 -2. So the dimension of acceleration is LT raised to power -2. Next one is force. What is force? Force, using the formula. Remember, in dimension, to find the dimensions of any quantity, you must know their formula. So the formula for force is mass times acceleration, which is ma. Mass times acceleration. So now, forming dimension of force now, mass already has this dimension, which is m. So you put m, a, which is acceleration, we have formed it immediately. So no need of killing ourselves again. So we can take this and put immediately. So it becomes MLT raised to power -2. Dimension is so easy in physics. Now, going down to pressure. If you remember, the formula for pressure is force over area. Force over area is pressure. Without the formula of these quantities, you can't find their dimensions. So now focus on the formula. So the formula for pressure is force over area, which is equal to, what is the dimension of force? We have done it to be what? MLT raised to power -2 divided by, what is the formula for area? Remember, area is equal to length times breadth. Recall that I told you that length is measured in meters times breadth is also measured in meters. And I told you, anyone that is measured in meters, the dimension will be, if you have to put it here, it will form length times breadth is also measured in meters, so it will form length also. So now length times length is now length squared. So the dimension of area is length squared. So this is not acceleration, rather it is what? Area. Now take this length square and bring it down, so it becomes L raised to power 2, which is length square. Now remember again, the rule states that nobody should be up and nobody should be down. So we bring down MLT. Okay, since there is MLT, since there is L up and L down, so we'll pick one L. Remember, law of indices. So there's one L here. L is having 2 up, it will go up and change to -2, and t will come down as t raised to power -2. Forming it, nobody is up now, nobody is down. But we can't stop here because there is something to be simplified here. So now the final answer will be L 1 -2 is -1. Then t raised to power -2. So this becomes the dimension of force, of pressure. Now, today we'll be stopping. I'll give you the one you will do. Post the answer under there, like and comment. Thank you.